Here we have three scenarios in this video. First, let's see what happens if we remove the sun from the solar system. Don't forget to like and subscribe. So I will select the sun. Let me pause the simulation, and now let me hit the delete button, and now I'm gonna run the simulation. So as you can see, we don't have any sun in our solar system in this simulation. So let's see what happens to our planets of the solar system. So I will run the simulation and let me speed it up. As you can see, the planets are no longer held by the sun's gravity, and they would continue in their current paths at first, but then they would drift off into space in straight lines. As you can see, here we have Venus, Mercury, Earth, and etc. And also, when we don't have any sun here, so let me select the Earth. Here we have, Earth and other planets would cool rapidly without the sun's heat. Eventually, they will freeze out. And also, there is total darkness. The solar system would become dark with only distant stars providing a faint glow. As you can see here, we have some stars providing a faint glow. And now you can see that the Earth temperature is very, very low. As you can see here, let me slow it down. So Earth atmosphere would eventually freeze and fall to the surface as snow. And the same could happen to other planets with atmospheres. So maybe we will have potential collisions after we remove the sun. Without the sun's presence, planets and other objects could collide with each other in the solar system. You can see chaos in our solar system after we remove the sun. So this shows that how crucial the sun is for our life, but the sun is not gonna be there forever. So it's gonna get bigger at the end of its life. It's gonna get bigger and bigger, and then it's gonna destroy the sun. Let me show you how. The sun, like other stars, is a giant nuclear reaction in space. Its fuel comes from a process called nuclear fusion. So we have hydrogen fusion in the core of the sun. The sun's core is extremely hot and dense, and under these conditions, hydrogen atoms smash together to form helium and releasing a tremendous amount of energy. And this energy release is from fusion is what we see as sunlight, and we feel it as warmth in our planet Earth. So it's also what powers the sun and gives its glow, as you can see here. We have also balance of forces. The energy from fusion creates an outward pressure that balances the inward pull of gravity. So the delicate balance keeps the sun stable. Okay, now what happens when the sun runs out of hydrogen? It's a long process, but I'm gonna keep it short. The sun is going to be a red giant after that. In about 5 billion years, the sun will exhaust its hydrogen fuel, and it will start to fuse helium into heavier elements like carbon and oxygen. As a result, it will expand into a red giant, engulfing Mercury and probably Venus, and also it is gonna scorch the Earth. So I couldn't increase the mass of the sun because it's gonna turn into a black hole in this simulation, although we know that in reality the sun won't be a supermassive black hole. Let me pause the simulation, select the sun, and let me delete the sun, and instead of the sun, let's add a supergiant. Like maybe Betelgeuse. You can see Betelgeuse here, or maybe Antares. Yes. So the sun is going to be, probably it's going to be something like this in a red giant phase. And after that, eventually the sun will shed its outer layers, leaving behind a hot core called a white dwarf. This white dwarf will slowly cool down over billions of years. Let's run the simulation to see what happens, and also note that the sun's white dwarf will eventually become a cold, dark, and dense object called a black dwarf, and it is going to mark the final stage of its life cycle. As you can see, all of the planets are gonna get destroyed by this massive star. So while the sun has enough fuel to last for billions of years, its eventual depletion will lead to dramatic changes in our solar system, as you can see in this simulation. But don't worry, this is all very, very far in the future. Okay, and now we're gonna replace the sun with a black hole of the same mass. The solar system would experience some dramatic changes, but not in the way you might think. So let's see what happens. Again, we pause the simulation, we select the sun, we're gonna delete the sun from the solar system, and now we're going to add a black hole of equal mass to the solar system. Sagittarius A, no, it's a supermassive black hole at the center of our Milky Way galaxy. So the black hole one solar masses is like here maybe. Okay, well, let's see what's going to happen now. Here we have the black hole, and let me run the simulation. Oh, I didn't make it still. Again, I'm gonna pause the simulation, select the sun, then delete the sun, and in the center of the solar system, let's add a black hole, but make it still, not in the orbit. We don't want it to move. So the black hole one solar masses is probably it's going to be here. And now let's see what happens. So let me run the simulation. As you can see, the orbit of Mercury somehow changes. It's because I put the black hole in a wrong place. The planets, including Earth, would continue to orbit black hole as just they do to the sun. This is because the gravitational pull from the black hole would be the same as the sun's, given that their masses are equal. So, but if we look at the sun, we would see that there is no light. I mean, the black hole does not emit light like the sun does, so the solar system would become a very dark place. And also we have freezing temperature on Earth, as you can see again in here. Let me slow it down, slowing down the simulation, and now Earth and other planets would cool down significantly due to the absence of the heat from the sun. So we will have a frozen world. That's it. We've seen that how important the sun is for our solar system, and also how important it is for our life. So thank you for watching. Stay curious.